Yes, this is a very, very ugly definition. We're going to try to make it not be so scary. We're going to deal with this yellow part first, right here, where n is a non-negative integer. The first thing you have to know is that when they talk about n, they're talking about the exponent of a variable. Yes, I know there's an n right there and there's an n right there. But n in this case is defined to be the exponent of a variable. We'll talk about this in just a second. So what do they mean by non-negative? They just mean non-negative means that it's a positive, but so you may be asking, why didn't they just say positive? It's got to be a positive number. Well, because non-negative is talking about positive, but it's also talking about zero. Zero is neither negative nor positive. So what they're telling you right there is the exponent on a variable has to be a positive number or zero. What do they mean when they say integer? Integer is a group of numbers that contains no decimals or fractions. So it's got to be a positive whole number or it's got to be zero. Now, I do want to remind you of something that you learned in Algebra 1. In Algebra 1, you learned that anything raised to the 0 power has a value of 1, and you also learned that negative exponents can be rewritten as a fraction, where this variable right here has an exponent of -1 that can be rewritten as 1 over x to the positive 1. So these two rules right here are going to be necessary to be able to correctly identify things that are okay and things that are not okay. This is an example of a polynomial, and it's okay because the exponent on each one of these variables is a positive number. Notice that here's the variable x, the exponent is a positive 5. Here's the variable. This exponent right here is a positive 3. This is not a variable. It is a constant. It's a number. Its exponent doesn't matter. Okay, so what you're doing is you're looking for an exponent. Now, one thing you might want to recognize is that even though this looks like it doesn't have a variable, it really does. This variable just has an exponent of 0. Anything with an exponent of 0 is a value of 1, so that becomes a 1, and 1 times 4 raised to the -2 is simply 4 raised to the -2. So just remember, if it appears that it doesn't have a variable, it really does. The variable just has an exponent of 0. That may help you in later problems. But this thing right here is okay because this negative exponent is not on a variable. It's on a number. These over here are not okay. You may say, well, here's a variable, here's an exponent. Here's a variable, here's an exponent of 2. That's okay. Here's a variable, its exponent is 1. That's okay. But yes, where is that variable? It's in the denominator. So that means that 1 over x can be rewritten with a negative exponent. And since it can be, it can't be included in this. That right here breaks the rules. Okay, here's another one. Here's your variable, here's your Here's your variable, here's your exponent. It's a 4, that's okay. Here's your variable, here's an exponent. Some people are going to say that's a 2. No, it's not a 2. It's the square root of 2, and the square root of 2 has a decimal value. The square root of 2 is about 1.4, so that is the same thing as a decimal. This one is okay. If I had this 3x to the 4th minus 6x raised to the square root of 4. Why is that okay? Because we know what the square root of 4 is. The square root of 4 is 2. So even though it may be presented to you with the square root right there, it can be simplified, and the square root of 4 is just really the value of 2. 2 is a non-negative integer, so that one would actually be okay. It's not simplified, and it shouldn't be, we shouldn't stop with it until it's simplified.